Which one are you talking about?
The lab that it's being worked on. It's
The
a
lab
5.
the lab we're working on 5-5
Okay.
is Dalton's law of partial pressures.
There we go. I got it. Thank you.
All right. All right, so you have the 4 tanks with each a different type of gas with its molecular weight indicated. Okay, so now we go to number 2. It says select one of the ideal gas cylinders by clicking on the white label. This is your option. You can choose whichever one you want, and so that everybody will be doing the same thing. I will say we will choose number 2, 4, and 6.
Okay, so are we doing number 1 at all, or just 2, 4, and 6?
2, 4, and 6.
Okay.
He wants you to do 3 different gases, and I'm suggesting I want us to do 2, 4, and 6.
Okay.
Chanel, the gases, not the questions for the lab.
Okay, so the gases that we're using, it's ideal gas number 2, ideal gas 4, and ideal gas 6, correct?
Yes.
Okay, perfect.
Okay, so, and then it says you click, so first of all, you choose that ideal gas white label. You're gonna click 2, 4, 6, and then it says click the red arrow on the brass cylinder valve, which is, oh, where are you?
The increase flow button?
You take 2, and then it says for you to increase flow button by clicking on this. You probably have to click it 3 times to get to the 400 that is talking about.
Okay, do we have to change the moles inside the balloon box? Or
no, you're
machine?
not changing anything. You just I really shouldn't be doing this for you, but I'm helping so that we can all be doing the same thing.
Yes.
So it says you click the red arrow, which is this, and if you click it 3 times, it's gonna give us 400, whatever that dial means. Okay, if you have worked with gas tank before or respiratory therapist, you see that it has all these inlet and outlet. When you open the thing, it shows you an inlet pressure and then outlet pressure. But that is beyond what we're supposed to do. Just make it to 4 according to your own lab. All right, so when you put in the 400, then it says add this ideal gas to the balloon by clicking the green open valve. You can see it there. You open, you switch it once to add gas, and again, you stop, switch it again to stop. So you go, and it inflates. Please do not inflate it to full because you're gonna add 3 more gases to that particular balloon. So this is enough. And if you looked at that particular dial to the last one below, it says 0.083. Maybe you can make it up to 120 or whatever, but don't fill it up.
Where do you see 0.083? This is what I'm...
Are you looking at that lab?
Yes.
And what do you see to the, do you have a red balloon inflated?
Yes.
Okay, so by the left of that balloon, you can see 3 dials, 1L, 1 ATM, 1K, and the last one doesn't have any label, but that is the one that will read some kind of value,
okay,
which is really the moles of gas that is being studied.
Okay.
So,
So
that
if
is,
I had stopped it before the 0.8 something that you said, if I stopped it before that, does that matter?
you stop it in such a way that you still have enough room to add more gases.
Okay.
All right. So and then he says, after he said that to you, it says, add an amount of your choice, but do not fill the balloon too full, since you will be adding 2 additional gases. So then it says, return to tank. You see where the return to tank, if you click on that, looks like somebody's moving gas tanks. So now you're gonna add the gas, ideal gas 4, which is the 4th one there. You do that. Again, you open the valve and let ideal gas number 4 go into the balloon. And you're gonna do it. It would be nice for you all to do it the same way. So right here in the one I did is telling me that it is 0.204. And the lid has changed, but that's not important because Dalton's law has nothing to do with volume. It just talks about moles and partial pressure. Okay, so then you return to the dial that says return tank. You hear that noise again. And since we're doing 2, 4, and 6, we now click on number 6. And we open the valve and let it, we don't want it to explode. So now we have enough of the balloon that we need. Okay, it says if you do have the balloon explode, you should just click the reset button located on the upper right of the gas chamber, and then you repeat the experiment. So if your gas balloon exploded, don't panic, there is a solution. All right, so now you have the physical parameters set. So it is time to return to the lab, and it's time to go to number 4. It says, click on the experimental apparatus to zoom in. If you place your cursor on the balloon, it will say zoom in. You just click it, and it shows you the lab by itself. Okay, does everybody see that?
Yes.
Thank you. So now, looking at that balloon to the left of it, you have the later 7 point. For my own, you're gonna write your own. You're gonna have your own 7.678 liters, and the second one we say 1.000 atmospheres, then 298.00 Kelvin, and 0.314 moles, according to my own addition. All right, so do not worry, because if you look at the dial that says atmosphere, it will show you the gases that you are working with. The gas, the one is 2. If you click on that 2, it would show you the number of the pressure that the first gas added. You click on 4, it shows you the pressure that the second gas added. And if you click on 6, it should show you the pressure that the third gas added that make up that balloon. All right?
Is there supposed to be a minimum that we are supposed to put in for each gas?
No. You just do what you know. There is no minimum or maximum.
Okay.
Then you don't do anything with the temperature because Dalton's law is on constant temperature.
Okay.
Then you go down to the modes, which is the last dial. If you click on 2, it will tell you that when you opened that valve, you added 0.123 moles of gas. When you clicked on 4, you added, for me, 0.81 moles of gas. And when you clicked on 6, you added 0.110 moles of gas. Yours might vary depending on how long you held that the gas to go in. So it says for you to record all this on the data table, which is below number 4. Record this in the data table. So ideal gas 2 has this amount, ideal gas 4 that amount, and ideal gas 6 has that amount. And then when you did the pressure, you read off the pressure that it has and you record each in its own row. That is the data collection.
Professor, I have a question. For the atmosphere, mine isn't at 1. Does it have to be at 1 for the total?
No, it shouldn't be at 1. But what you should know is if you added 2, the pressure of 1, the pressure of 2, the pressure of 4, and the pressure of 6, it should come to 1.00 atmospheres.
Okay, because mine is at 0.987.
So what's the deal?
So do I have to just do it over and try it again? Because my numbers are very close to yours, except for that it doesn't total out to 1.
Well, if you want to be meticulous about it, if you click on the last number of that your value, it should give you 1.000. Try it.
Okay, I just pressed the R and it went. Thank you.
All right. So because if you go back to do it over again, you might get more than that or again less than that. So you just work with what it has, and if you want to convince yourself of what you did, then you just click something there and it will give you 1.000 atmospheres.
Okay, are we supposed to draw a graph?
No,
One graph or a graph per gas container?
This lab has no graph to draw.
Okay.
And after you have filled out that particular table under number 4, if you add up the partial pressures, it should give you 1.000.
Okay.
And then the number of moles should give you a particular value also. For instance, if you clicked on that total, it will give you the total number of moles of gases added.
Can you say that again?
If you click on total on the moles dial,
right,
it should give you the total number of moles that you added.
Okay.
So what does it tell you?
Well, it tells me 0.394, but yeah.
So that is the total number of moles of gases that are in that pink balloon.
Okay.
Professor, this is Jason.
Mm-hmm.
Yeah, for my number of moles is actually lesser. Is that okay? It's 234 instead of 314.
How
And,
big is your balloon?
it's a little smaller than the one that you have on the screen. And then the volume is only 5.722. I
Okay,
adjusted the pressure though to 1000 and the temperature to 298. It's already like that. Only the volume and the number of moles are different.
The number of moles of yours should be different from mine because my own click and the duration of the click is different.
Right.
But eventually it's going to give you the same information that the pressure in a gas is the total pressure of the individual gases in the content. So I don't want you to, you can do it over again to increase the number, but then you might run the risk of either making it burst. Okay?
Okay, thank you.
Then you go to number 7 on page 2. It says, another way of expressing Dalton's law of partial pressures is with the expression Pi, which is the pressure of a gas, any gas, is equal to the mole of the gas times the total pressure, where Pi is the partial pressure of gas I, and Xi is the mole fraction of that gas in the gas mixture.
Can you explain how you're supposed to solve for each partial pressure again?
No, you mean according to number 7?
No, I think she means
I mean number 4. I mean number 4.
Just press the numbers. Just press the numbers under like pressure, and there's what we did. The gas is 2, 4, 6. Just press 2, 4, and 6.
You see, so you are trying to fill table number 4.
Okay.
You got it now?
Yes, thank you.
No, thank who was that helped out?
Yes, thank you also.
Is that
You're welcome. No, it's right. Christiana. Thank
you. Okay, thank you. All right, so when you filled out that table, then you go to number 7, which is now telling us that another way of expressing Dalton's law of partial pressure is with the expression that pressure of a gas is equal to the moles of the gas times the total pressure. Okay, so then you're using that particular equation, you fill out the data table below 7. Ideal gas 2, ideal gas 4, ideal gas 6.
Professor, I have a question. For number 5 and number 6, I don't know if I'm not understanding it properly, but aren't they the same answer? Are they both 1 or?
That is exactly what he wants you to find out.
Oh, okay.
That's really what he wants you to. You did that and you have a value. So you write it there. It says, using the information from the data table, determine the total pressure in the balloon. So you use the pressure for gas 1 plus pressure for gas 2, and also so it gave you a long enough space to show how you're gonna get that.
Okay, so when you're filling out the partial pressure calculated, do you just guess a number or?
No, you are not guessing the number. The number is right there on the dial.
Okay, but how is that different from measured?
The measured is the one that you see right there before you started. It says 1.00 atmospheres.
Right.
All right, so then you did those 3 operations of filling the balloon. And when you are filling the balloon, each time you press, open the valve, a particular amount goes in, you stop, you press it again, a particular amount goes in, you stop, and then you did the 3rd time. All right, so it tells you on number 4 that ideal gases 1 to 8, that is what you're going to be looking at. That the 3 gases that you selected will be highlighted, which is what I showed you below. Dial number 1 is liters, number 2 is atmosphere. If you press on the dial, the highlighted number 2, if you press on it, it will give you the amount of pressure that the gas number 1 put in the balloon. If you press on 2 or number 4, it will give you the amount of pressure that gas number 4 added in the balloon. If you press 6, it will tell you the amount of pressure that gas number 3, which is in this case 6, add in the balloon. And that is what you're going to put in that table under number 4, partial pressure PI point, whatever it is. And then you skip the temperature, which should be constant. You go to the number of moles. If you click on gas number 2, it should tell you the number of moles of gas that you added. You click number 4, it tells you the number of moles of that gas that you added. You click number 6, and it gives you the number of moles of that particular ideal gas number 6 that you added. And then if you click on the number total, it tells you that if you add the moles of 1 plus moles of 2 plus moles of 3, it will give you 0.314. So what it's saying there is, if you were to add up all that partial pressure that you saw, do they equal, for instance, 1 atmosphere? That's what number 5 is telling you.
Okay, so I'm still confused on number 7. How do you determine the calculated and the measured?
Are you through with number 4 and 5 now? Because I don't want to come back to it.
Okay.
Table 4 means just adding up the partial pressure of each of those 3 gases. It should give you 1.00. And in the moles, if you add it up, it should give you 0.314. That's what that is telling you to do. So it tells you to compare your total pressure, which you have calculated by adding up those 3 numbers. Does it agree with what is shown on the dial?
Where's the dial?
Where have you been looking at?
I've been looking at the video that's on my phone. I couldn't get it on the computer.
Okay, so that is why you're having this problem. The the dial is, do you see the balloon?
Yes.
Okay, to the left of the balloon, there are four dials.
Oh, okay. Those are the dials. Okay.
Professor, for number 7, I want to make sure I am inputting the numbers correctly. Are you solving for P total?
You are,
or P measured, I think it's,
you are solving for P measured.
which is P total, correct?
The P measured, for instance, in number 2, the P measured is 0.104. And the P total would then be the mole fraction of that particular gas number 2 times the P total, which is what you got by by adding the 3 pressures. Did you bust the balloon? Yeah. You going somewhere? Come on, guys.
Professor?
Yeah.
So for today's lab, are we turning in number 7?
You are turning in, I want to see what you did on number, data table number 4, 5, 6, and 7.
4, 5, 6. And then, and it should only be one set of numbers, correct? Since I'm pretty sure everyone in the lab group will have like different numbers.
Yeah, it should be one, so which means you agree with your group that this is what you're submitting.
Okay.
In the morning group, some of the groups, their number, when they click the thing to fill the balloon, sometimes they will just fill it and then they don't have any space to add the second one. So they consulted with the group, and somebody or 1 or 2 people did it, and they combined it.
Okay, so just again, we're doing 5, 6, 7, and 5, 6, and 7, right?
You're also going to show the table below 4.
Okay. What table? Because number 4 it's not.
There is a table below number 4.
Oh, okay. I see it. Thank you. Okay. I'm sorry, sir, but were we supposed to do all 10 gases or did we just choose 3? Because number six says compare your answer from number 5 to the total pressure on the meter.
Yeah, on the meter. You know, you just did 3 gases.
So
The pressure on the meter is what are you seeing there? 1.000 atmosphere.
Do I change it?
You don't change anything. You only change it when you are adding the moles. So when you do all those things, does it add up to 1.000 atmosphere?
Chanel,
Yeah.
you're only doing numbers, the gases 2, 4, and 6, but on the worksheet, number 5 is in reference to, or for number 6, it's referring to number 5. So you have to compare the answer for number 5, not the gas.
Okay, but do I still test out the 5 for the answers to compare them?
Do you still do what?
No, go ahead.
It's just asking you what the total pressure is in the balloon for number 5.
Okay, but if 5 doesn't allow me to click it, do I compare it to number 4?
No. You're not doing the gas number 5. You're just determining the pressure.
This is what I'm.
So your pressure is, well, what I have is 1. And
all the total pressure for the 3 gases should add up to 1.000 atmosphere.
Okay, so I just add all 3 together.
Yeah. Does it add up to 1, which is the total pressure in the balloon you are looking at?
Okay.
Good to see you, Jessica.